Hello everyone. So this is looking at for 6.2 law of cosine. There are three basic formulas for law of cosine that you're going to be asked to memorize. And they're actually just one that you really need to pay attention to, and you can get all three of them. What I want to point out is that this side always has its opposite angle across from it on the other end, that you're taking the cosine of the angle that's paired with that side. So for example, B is here, so you're going to have angle B there. Side C is here, so angle C is there. The other two sides, so if side A is there, these have to be the other two sides. And those two sides are right here. These two sides are right here. The other two sides are right here. So by just knowing one of these patterns, you can write all three of them. So again, this angle and this side are always paired. The other two sides are always here. So most frequently when kids make mistakes and they're filling this thing out, let's say hypothetically they're using actual numbers, plus c squared minus 2, let's say they go AC cosine of B. So say they're using numbers, 3 squared plus 5 squared minus 2 times, I don't know, whatever A is, times 5. That right here, this should be 3 and 5. Okay, these two numbers should match these two numbers. Okay, so that's the most frequent mistake, is kids don't write it in the right order. These two sides have to be these two sides. So when your calculator tells you error when you're doing something, check and make sure that those two sides are actually these two sides. Okay. Next one, if you're told two angles at a side, then it's going to be a law of sine problem, not a law of cosine problem. The law of cosine problem just won't work. Sorry for the interruption, you guys. The custodian came in, so I paused it. If you're told two angles at a side, you automatically are going to have a pairing. So that's going to be a law of sine. So automatically a pairing. Now here you don't have an angle C, but because you know two of them, then angle C in this case has to be 100 degrees, so you know a pairing. Okay? So two angles, and you automatically know it's a law of sine. It could be a law of sine if you only told one angle, but you have to look at it a little more closely. So here, automatically, when you're told three sides, it has to be a law of cosine problem because you do not have a pairing. What you guys are going to be looking for is angle A, angle B, and angle C. When you're told three sides, it doesn't matter which one of these you find first. It makes no difference whatsoever. So how about I just start by finding angle A first. So if I'm finding angle A first, I have to write the formula that has angle A in it. And the formula that has angle A in it is this one. I want angle A, so I'm going to solve for angle A. You guys can either fill numbers in right away. I would caution you a little bit about that, and that kids make a frequent mistake, so I'll start filling it out. 5 squared is equal to 4 squared plus 3 squared minus 2. Remember, 4 times 3. These two numbers have to go right there. Cosine A. I would strongly advise you guys do not start typing this stuff in your calculator. Just move stuff around as is. Because what frequently happens is kids will go 25 equals 16 plus 9 minus 2 times 4 is 8 times 3 is 24. Cosine A. And somehow they think that they can go 25 is equal to 25 minus 24 cosine A, and go, okay, that's going to be 1. 25 is equal to just cosine A because I have 1. No, that's wrong. You can't combine this. Absolutely not. You can't, because this is multiplying. You can't bring this together. Don't do it. Okay? So I'm just saying, just don't. Okay? My advice is it causes more trouble than it's worth. Most of the time when a kid calls me over and says I'm having trouble with it, it's because that's the process they're going through. It's not that I'm trying to be dogmatic and say you guys have to do it my way. I'm just saying from experience, kids that struggle with it do it that way. So what I'm suggesting is that you start cutting this stuff off as if you're solving for a. So I got 5 squared minus 4 squared. Back up a 4. Alright, 4 squared minus 3 squared is equal to negative 2 times 4 times 3 cosine A. All of this stuff is held to cosine by multiplying, so I'm going to divide it out. Sorry, that's a 4 again, you guys. Minus 2 times 4 times 3. I can exaggerate my 4's, and notice these two numbers are these two numbers. That's not by coincidence, okay? So this stuff all cancels out. So I got 5 squared is equal. Boop. Minus 4 squared minus 3 squared over negative 2 times 4 times 3. And I'm going to throw this thing across the room because it's still not liking my 4's. Okay, equals cosine of A. So to solve for A, I have to take the inverse cosine of both sides. So that cancels that out. Now, when you guys go to type this in your calculator, I'd again suggest you type it just from start to finish. You'll need a parenthesis here, and you'll need a parenthesis here. Okay? Including the blue one that I had originally. But you're going to need everything there that I showed you. Okay? And then that'll give you angle A. Assuming your calculator's in degrees, okay, because we're like to keep it in degrees, so keep it in degrees, okay? To solve for angle B, then you set up the pattern where it has angle B in it. So you have B squared is equal to A squared plus C squared minus 2AC cosine of B. You could fill these numbers straight in, or if you guys want, I'm trying to lead you towards, what if you solve this equation first? B squared minus A squared minus C squared. This stuff is all held by multiplication. So if you want, I'll slow it down. I was going to jump ahead. Whoops. Can't talk and write at the same time, apparently. Cosine of B. This stuff is all held to cosine by multiplication, so I'm going to divide it out. Once again, notice those two sides are those two sides. So this stuff is gone. Now I'm going to take the inverse cosine of both sides. And if you guys want, you can just fill the numbers in right here. So inverse cosine. So I'm going to have, let's see, a B is 4 squared minus 5 squared minus 3 squared over negative 2. And remember, those two numbers are going to appear on the bottom. Okay? And you're going to need a second set of parentheses. So here and here to type that thing in your calculator. And that's going to tell you angle B. Now that you have two angles, you could just cut those two angles off of 180 to get C. However, if either of those two angles are wrong, you're automatically going to be wrong for C. So once again, my advice is you set this up for C. So C squared is equal to the other two. I guess I'll do them in an order that you guys might like better. So A squared plus B squared minus 2AB cosine of C. And solving it to look like this is going to be inverse cosine. So then you're going to have C squared minus A squared minus B squared all over negative 2AB is going to be angle C. Okay? It really doesn't take long to type it in parentheses. One less parting shot is make sure that you put those other parentheses in there, and then you're going to have all three angles. Okay, when you're given one angle and two sides, how do you know if it's a law of sine or law of cosine? Do you have a pairing? In other words, sine of A and A. Do you have an angle and its side? No, I don't. So automatically that's a law of cosine. If I tried to set up, say, B squared is equal to A squared plus C squared minus 2AC cosine of B, if I try and set this up, I'm stuck. I need to show it 4 squared is equal to, I don't know, A squared plus 3 squared minus 2, I don't know, A times 3 cosine of b. I'm stuck because I have two variables in the problem, two different variables. I can't do it. So how do you know which one to start with? You start by finding the side that's opposite that angle. So it's a squared is what you have to find first. So 4 squared plus 3 squared minus 2 times 4 times 3 times the cosine of 15 degrees. And to solve for a, you just have to square root both sides. And you type it as you see it, just start to finish. Big old square root, 4 squared, blah, blah, blah. Just type the thing in. Enter, boom, out pops a, side a. Once you have that, then you can treat it like these and find angle B and angle C. Okay? I personally don't think it's worth memorizing the formulas for it. If you're good at memorizing and you want to do it, by all means do it. If you want to find angle B, then angle B is going to be equal to, let's see, that's going to be b squared minus a squared minus c squared over negative 2ac. And all that is you're doing the inverse cosine of it. All right? Where did I get it? I got it from b squared is equal to a squared plus c squared minus 2ac cosine b. And all I did was solve for b just like I did on this previous page. Okay? There it is right there. This equals b. Okay? So I think it's only worth memorizing this. And then you solve very quickly, in a matter of seconds, the formula and fill your stuff in. If you guys are struggling with it, please come and seek help on it, because it really isn't meant to be that bad. I respect if you're finding it hard, but like I said, don't just continue to struggle with it. Come and get help, because it should be easy. And you use that process then to find B and C. Okay? Is this a law of cosine problem? No, because you have a pairing. Whenever you have a pairing like that, it's automatically law of sine. Okay, will there ever be an ambiguous case in law of cosine? The answer is no. You'll never have an ambiguous case, and let me attempt to try and show you why. If you remember back to the ambiguous case with law of sine, the shortcut, or the long and the short of it was, if you were meant to have an obtuse angle, so let me use the vocabulary again. Okay. This would be an obtuse angle. It's an angle that's bigger than 90, or if perhaps I didn't exaggerate that enough, let me draw it perhaps like this. Okay? That clearly you guys can see this angle down here is definitely an obtuse angle. An obtuse angle is an angle that's larger than 90 degrees. So if you have a scalene triangle where all the angles are less than 90, so I'm intending this to be acute, all of these are acute angles, you will not have an ambiguous case. If that's what, acute. If your triangle is meant to be acute, it'll tell you it's acute. When it's not, when it's ambiguous, is if you're going to have an obtuse angle in your triangle, an angle that's larger than 90 degrees. Then you don't know if you're supposed to get it or not, because if you remember on law of, on sine, inverse sine, all your answers for inverse sine were going to be between negative and 90 and 90. If, say you had sine of theta is equal to the square root of 3 over 2, it could happen here at 30, or it could happen here at 150. Okay? There's two different locations it could happen that could fit inside a triangle. 30 and 150 will make up a triangle. Okay? Now here, cosine, where is it square root of 3 over 2? Right here and right here. So 30 degrees and 330 degrees. That's not fitting in a triangle. So there's only one answer to this question that makes sense, is within the context of, give me a triangle where this is going to be true. You're not going to have an ambiguous case, because 330 degrees ain't fitting in a triangle. Okay. This next one, whoops, let me get rid of it this way. All right. Where is cosine negative square root of 3 over 2? Right here and right here. Again, this is going to be 150 degrees. And this angle, as you guys know, is 210. Not going to make a triangle, where this one will. So if your angle is meant to be obtuse, it will tell you it's meant to be obtuse. If it's meant to be acute, it's going to tell you it's supposed to be acute. So this one was when you had law of sine, or not law of sine, sorry, inverse sine, your angles could be between negative 90 and 90. If it's meant to be obtuse, it ain't telling you. Whereas with inverse cosine, if it's meant to be obtuse, it will tell you it's meant to be obtuse because it will return answers between 0 and 180. So there's no chance it could be ambiguous, like, is there another angle that might work? And if there was, it would tell you, okay? If it's meant to be obtuse, it'll tell you it's obtuse. You don't have to guess at it, okay? This is just doing it on non-unit circle angles. I'm not sure there's going to be any more information to be gained from it, so I'll skip that, and that should do it.